Hello everyone, we're back. We're going to be grinding some more on Keith Rucker's column square. This time we're going to do the V's. This will be the tricky part and the harder part. And before we go there, one of the subscribers, Emerald Machinist I believe it was, he asked about the math, how I figured on squaring this block. When we first started with the block, it was out a total indicator reading about 3 8/10, if I remember right, something like that, out of square. And so I'll show the math, and I'm going to use different numbers so that it's easier. And so what we have is we have a square block, and it's out, if you measure from one side to the other, a total of 4 thousandths. And that means it's out a square per side, 2 thousandths, because you'd split that in half. It's 4 total indicator reading, meaning 2 per side. And so what we do, and what I was measuring was, here's the contact point of the nose radius on the square gauge. Here's the indicator tip, where the distance between the nose and the indicator tip is 5 inches. And I'm just using these numbers. They're different because it's easier to understand. And so what we have in this 5 inches, even though the block is bigger, we're measuring in 5 inches. And the 5 inches, it's out 2 thousandths per side. Well, the base of this block is 2.5 inches. And so what we need to do is find out a ratio, how far out of square, or not how, we already know how far out of square. But when we grind a step in here for a shim, how much do we grind off in order to make a step in there so that it's square? If your block is leaning this way, it means it's high on this side, and that means you need to grind a step over here and cut down, and then that way your block can lean back over here. If it's out of square in this direction, well, then you just put the step the opposite way. So basically, it's because we want to find the ratio between this side and that side. If I'm 2 thousandths out here to here, I'm not going to be 2 thousandths out here because this number is not 5 inches. It's half of it. So basically, if I take 2.5, this side right here, the smaller side, over 5, that equals 0.5. And if I take that 0.5, and I know that I'm out 2 thousandths per side, I can take 2 thousandths times the 0.5, and that will equal 1 thousandths. And so that means that I will have to grind a step in this block, and that means that this distance from here to here, that step amount would be 1 thousandths of an inch. And then that would let this block lean back over that one, or the 2 thousandths in that 5 inches. And so doing the math like this, I can get really close. And sometimes you have to tweak it in. And sometimes you can get really close and it's just not quite there, and you might only have a tenth or two. That's just a matter of setting it up and putting a dry mark on there and taking a blank pass on the one side, because you're talking less than 50 millionths sometimes just to get that to move a tenth or two. And I think it was Brian Block that wrote in the comment that he said that I made this look easy. Well, in actuality, this block was easy because everything just fell in place, and it's unusual. Usually it doesn't do that. I usually have Uncle Murphy, he visits me, and he makes things difficult. But because the block that we were measuring, I scaled 5 inches. The block we were measuring from here to here was actually 1 inch 575 thousandths. But that I'll just draw it at the top, but we had the V in the block, and even though it was 1/575 in this direction, I had a little flat here and a little flat here, so in reality my step number would have been by the V's if I would have been more accurate. Well, the math that I did when I figured this out, at the 1.575 came out to where I'd have to grind one side lower 5.5 ten-thousandths of an inch lower than one side. Well, that's the way the math worked out, and I only went about 4 to 4.5, and the reason it worked out perfect was because instead of being the 1.575, I was actually measuring from this edge to that edge, which would have been a smaller number. And so by chance, it just worked out. The first try, it hit it just about right on the money. So doing the math, you can get really close to what you need when you want to square up a block this way. And what we're going to do, we're going to grind the V's now. And we're going to use the same wheel. It's a silicon green carbide wheel. It's a Radiac wheel. This one they made that I asked them if they'd make a porous one for me. It's 60 grit. I wanted the porous because I wanted a cool cut on it. And the problem that we're going to have when we have this kicked over and we're grinding this V, if I use the entire width of the wheel, once I turn this up, the wheel would be in like this. If I use the entire width of that wheel, I'm going to have a huge heat signature. If I would come in from this way and grind in, what's going to happen? My wheel's going to wear down right over here, so the V will be near impossible to get flat. So I'd like to come in, plunge down, and walk out. By doing so, my wear is this way, but I can come all the way off, and so the lowest point of the wheel is from the bottom all the way to the top. The problem I'm going to have with that half-inch thick wheel, again, we got a huge heat signature there. And not only that, is I can't angle this on the magnet like I've done the other to make the engagement less, because I'd be hitting into these other sides. So what we're going to do with the wheel, we're going to do a little trick. If you have your wheel, I'll just draw it so it's like this. And instead of using the full half-inch to grind that V, and let's say that we got our V set up like that. What I'm going to do is I'm going to relieve about half of this wheel. I'm going to cut this like so. Oops. Kind of hard to draw like this. So I'm going to relieve this wheel. I'm going to start out with just about half the wheel, or a little bit less. I'll start that way so that my heat signature is going to be way less as I come across. And by taking it easy, it should work out fine. Right now we're going to go to the granite table, and we're going to show you the setup that I'm going to use to grind those V's. Okay, here's the setup that I'm going to use. I'm going to be using this sign plate. It's 10 inches from center to center. I just retouched this not too long ago and got it really good and accurate. The problem that you have when you start working with an angle and you start lifting things up, your error gets magnified sometimes when you're doing this type of work. And so you got to take a couple extra steps if you want that extreme accuracy. The other thing I had to do was that this base that I have for the sign plate right here, it wasn't going to be big enough. It wasn't long enough. It wasn't tall enough to actually cover most of this right here. And so if I could have probably put that on there and tried to toe clamp, but there's no support up here. And then if I start grinding on the V, I can get harmonics because it's just not a rigid setup. So I took a piece of cold rolled steel and I stress relieved it by throwing it in that oven that we got from Stan at Bar Z. I threw it in there between 11 and 1200 degrees at for about 4 hours, and then the oven would turn off automatically, and then I would just let it set overnight until it was completely cool the next day. So these surfaces, they were milled, but because of the heat and everything, I don't need those surfaces. I just needed it flat here, and this whole plate was flat, less than a 1/10,000th of an inch. But the thing that you have to watch for when you're working with angles, and you're going to see it in here. I'll demonstrate it on Key Square in a minute. What you need to do is you need to make sure that this plane and this plane that they're going good. The block that I have on the back, when I put just this pin, it's a very precision ground, very round, very true pin. When I would put that in there, it was 2/10 low, checking from one side to the other, which is actually quite accurate in 7 inches. And so what I did with this plate, I got 4 screws that will hold this plate on to that block, and in the middle I put a jack screw for 1/4 20, and this was the side that was low. So I got the plate snugged on there pretty good, not reefed down real tight, but real nice and snug. And I put a set screw in there. And then what I did is I adjusted the tension and everything so that I can get this pin so it reads over here. From my angle, it looks like we're reading right at 0. And it looks like we got it right on the money over here. It's at 0. So we eliminated that 2/10,000ths of a error. And the reason you want to eliminate that is because if you go to grind, you have your part on here, and you're low on this side, 2/10, high over here. When you turn this over, you're going to be low here and high here, just the opposite. And so what will happen is the plane that you're grinding right here is off 2/10. It's just the opposite on the other side, and it will cause some error. And so this is why you want to get that planed in. If you're doing V-blocks or anything with angles, you want to get those 2 planes that you're working from. You want them to line up as best you can get them. Let me see if I can find, yeah, here it is. And I mapped this out a little bit off camera, and I just want to show you guys some of the error that we have. And it looks like we got a big old fly visiting us. Might have to take care of him off camera here in a little bit. Photo bombing us. If you look at this V, we're right at 0. And we're about 1/10 high. So you're going to think that V is nice and square because it's reading right on. The problem that you'll find is that when I actually map this out, it was the error I was just talking about. From this side to this side's 1/1000ths low. From this side to this side, it's 1/1000ths low. And so what will happen, even though it was square in the one direction, if you would set it up in this direction, and let me see if I can do this without getting my hands too much in the way, and it's always kind of hard holding the V like this, so we'll see if we can get a decent reading, or at least one close enough.
See if you can slide it while you're set up back that way.
Back?
Yeah. That's good.
Okay. So we'll get position for the camera the best we can. So you can see we're about 1/10 high. And now you can see we're about a 1.5 out. So to square in this direction, but those planes are not going the same, and so that can cause all kinds of other problems as well. But it shows that the one direction it is out. So we want these planes to be as close as we can for accuracy. Now, the next thing that we have on this, is when I set this up to find out what kind of angle we had, I thought it was 15 degrees because I have a 15-degree template. I set it in there, and yeah, that's 15 degrees. It looks pretty good. When I started setting this sign plate up at 15 degrees, I noticed that I was way off when I'm measuring. When I was measuring in this direction. And you can see I'm off here. But the thing that I found out is that this V was off in a lot of, none of these V's are the same. They're all off. And they were not 15 degrees. The closest to a nominal degree I could get was 19 degrees. So here you can see this one here is pretty close. It's a little bit higher, but you can see that's pretty good. And that was the V that I figured I'd start working with. So anyhow, what I did is I just kept playing with my gauge blocks until I got the one side very close. The other sides are close, but I think that worst side was what you just saw, is about a thou out. It turns out that by doing the math, that the actual angle that this is set up on is 18 7/8 degree. So I have no idea what the original setup or what it's supposed to be, but I'm just going to copy what they have in here the best I can. And so, Keith, if you want to know what degree that is, write it down. It'll be 18 7/8 degree. And so what we'll do is I'll get this strapped up. And we got a strap where I can pop this in there and hold this on so we can grind this. I got to change the wheel out. Actually, I got the wheel on. I got to actually get the grinder going and get the wheel dressed and get our setup. And then what we'll do is we'll come back and we'll start our grinding. Okay, I got this set up right now. You're not going to be able to see the grind because it's going to be blocked. I'm real close. I haven't touched off yet. But what I did is I got to where that relief is in the middle, and I came back as far as I could without touching the other side. And here's the beauty of having a digital and the Y. I set that to 0, so I know where to stop on that. And so right now I just got to lightly touch in, and we'll take our first cut. One of the other things, people have been complaining about the noise that these handles have made. So another guy made a suggestion about some plastic washers that he made up. I just took a peanut butter jar plastic lid and cut out and made some plastic washers, go in there and pump some grease in there, and it quietened it down. You might hear a little bit, but it should be a big improvement. Oh, and before I forget, with the sign plate, your angles, if you ever have to go over 45 degrees, you want to set it up different because your accuracy, you'll start losing your accuracy in your sign plate the higher you go. And the lower the angle you have, the better it will be. And I have a friend of mine from Instagram. Some of you probably already know him. His name is Simon. I'm hoping I'm pronouncing his last name. Simon Bouchard? But anyhow, he just started a new YouTube channel. His very first YouTube video, he's talking about this very principle of using the sign bar and the accuracies that involve, and he explains in detail why after you get past the greater the angle you get, basically the less resolution you have in your angle, and why at the greater angles it won't be as accurate as it will be at the smaller angles. And so he did an excellent job of explaining that, and so I'm going to put a link to his new channel down in the description. He's on Instagram. I'll put a link to that Instagram as well. He's got a lot of good material, very smart man, and I think you enjoy his content. And If you go there, I'm sure he'd appreciate if you would subscribe to his channel and leave some comments, and I believe he has a lot to offer the community. So I'm seeing sparks just a little bit on this one side. Now it looks like we're cleaning up almost all the way across. Set my Z to 0. Okay, I'm going to blank pass back in. Watching my digital so I don't hit the other side. And this is where you can't be daydreaming. You got to be paying a lot of attention. And I just about ate that fly. I think we're going to have to stop and take care of him. We'll have to do it off camera to keep the PETA crowd a little bit happy. Because that I'm going to get a daily dose of protein here in a minute. And I inked that up. We've got 100% cleanup. I'm going to take it off. And then what we'll do is we'll turn that 180 degrees. And I'm going to back it off about 5-6 thousandths right now. What I'm going to do is I'm going to wipe everything down, get all the grit, and if Adam can get up in here, and you can see I had it inked up like that, and it only took a couple tenths and it cleaned up. We got a very nice finish. Can you see that from there, Adam? Okay. How's that?
It's hard to tell.
Okay, well, it's kind of hard to get it with the light here, but you got the idea. Come back to 0 on the Y. I'm just going to ease in because I didn't check to see if that was central, which I'm assuming that it is. Now that's usually when things come back at you, you assume things that aren't right. At my age, I really ought to not assume things. Really should expect actually the worst. In this case, it looked like it worked out. So now I'm going to ease down. We had one viewer that requested that we show a picture in the picture of me actually winding the handles as well. I know some guys don't like that, but we're going to do that. I think what he wants to see is the actual feed. A lot of times when I'm traversing in the Y, I don't even think about it, and they ask what kind of step over I'm taking. Well, this Y is 100 thousandths per revolution, and I usually try from here to here to go about half or about 1/4 of a crank, so 25 thousandths to 35 thousandths. I'll do that on my finish. And now we're cleaning up, and we're heavy on the one end, and we're low on this side. So I'm not going to bring this V central in there. I could do that, but it's just going to be extra work and extra grind, and I can't see that there would be a reason for that. So we're just going to get them so that both of these planes are winding good. And one of the things when people, going back to the step over, they ask what kind of step over you're taking. And a lot of times when I'm flat grinding, I have a continuous movement on the dial. And it helps with the finish, but it would equate to, 25 to 30 thousandths in, per pass on there. But I keep it a continuous movement. And a lot of times I get asked these questions, and I got to think about it because I don't even pay attention to what I'm doing. It's automatic. So we're coming back with a blank pass. And we'll just pull this off after this and check and see where we're at. There we go. Okay, we got, actually, because when I flip this 180, I rotate it 90, so I actually got two of the V's ground right now. And we'll check them out. And you can see in this direction, we're right at 0. And here we're less than 1/10, about roughly 75 millionths, the best I can tell from my angle. And it's going to be really hard to get closer than that. What we're going to do now, the other side was identical. What we're going to do is we're going to set this down. I haven't checked this yet. Let's just see how straight it came out in this direction now. And if it come out straight in this direction, that means I only have one more side to go, and then it'll be ready to ship to Keith. And see, it's real hard to get this just perfect here. And I'll show you why once we check the side. So we're at the high point. We're just about 50 millionths high. And it looks like we're almost perfect there. I'd say I wasn't going to worry about getting these central. I don't see that there'd be a real need for that, just as long as they're square. So we're sitting right at about 0. And this one's off a little bit. This is okay. I'm going to check the other side again, but we're about +4 to 5. Okay, I'm reading about half high. There, so we're about 4.5 tenths that way on there. And one of the reasons I can be off a little bit on there is you see the relief area right here, how wide it is. The small diameter of this bar, when I'm in there, let me wind it to the side that I haven't ground yet. And what I'll do is put a little red ink in here. Now I don't know if you can see it or not, but our contact on that angle is only less than 1/8 of an inch from this edge up. So we're not checking, you know, way up, we're checking pretty close. So it's kind of hard to hold the pin in there with that small of an angle. You got 18 degrees, and at that tangent point, it's really hard to keep that pin from rolling, just holding it by your hands. But it is square, the direction that we want it. It's close enough that way. It's almost perfect on one side, within about 4/10 on the other side. I'm going to grind this third side out, and then we're going to check it, see where it's at from there. And if it checks out and it's as good if or better than the worst side there, we're going to call it a keeper. Grinding your V's and getting them just perfect is really hard to do. You're working in different planes and just a regular top and bottom grinds and regular squaring. The angle that you're working in makes a big difference as far as how accurate you can get on these things as well. Because like I say, when you turn things up at an angle, everything gets compounded. And oops. And I'm not reefing anything down. I'm just getting her down snug enough that I know it's not going to move, because I don't want to distort anything. Okay, here's the last side that we've ground. And we are setting at +3. And 0. And again, that direction I'm not as concerned about. We were quite a ways out on that. What I'm more concerned about is how square it is going to be this way. Yeah, that 3/10 side to side, that is really hard to get out. You can do it, but you just got to play with it, tweak things in. If you got just a littlest tiny piece of dust or ding on there, it gets magnified when you turn from one side to the other. So now let's see. Okay, just trying to get it perfect. Yeah, I'm probably not going to get it. It's about minus 25 millionths. And here we're about minus 2.5 tenths. So let's check the other sides out again. We may have to try to touch that one up a little bit. And actually, I'll have to check the bar because I probably didn't wipe it down good. I'll have to check that side again. So here we're plus almost 1.5. And now we're within 75 millionths on this side. So this side we're not going to touch. So I'm going to go ahead and mark it. And I wasn't trying to bring these to the same size either. I'm just trying to get them cleaned up. There we're at about almost minus 50 millionths. And that is almost identical. I mean, that's about minus 50 millionths. So this side is good. Now I'm going to flip it back over to the one side that I measured out because it may have been the fact that maybe I didn't have that bar cleaned off good. I could have had a little grit on the table, a little dust. There's a lot of things that can take place. It could be in the setup. But when you're setting this up, you can rub your this bar in here like that just to get it to seat good. Kind of roll it and go back and forth, and that way if there's any particles under there, there's a good chance that you'll get them to move out. We're just about plus 50 millionths. Oh yeah, see we had a little bit of particles in there. Right now it's reading within 50 millionths. So anytime you get a reading that just seems kind of strange and the other sides come out, always go back, clean things off, check it out because you're probably right on. And I mean, I could have had a small particle under this surface. I could have had some small particles under that surface. And when you're dealing with V's especially, you're working off the tangent point of this diameter, and you got to roll that, try to get if there's any dust, any speck of particle that's in between that tangent point and your pin, it's going to throw you out. So anyways, we're going to call this good. About the farthest out, we're on one side, is about 4/10 total. And so the other side, I think one was just about right on, and one side was within a couple tenths. But again, that I'm not too concerned about. What I'm concerned about was in this direction here. And it looks like Keith is now has an extremely fine-tuned column square. It's probably one of the most accurate ones in the country. And I'm going to let Keith, this level here is adjustable. I'm going to let him take care of getting that adjusted the way he wants. He's more skilled at that than I am. But this is just a really nice tool. And what a generous gift that one of his subscribers made to him. I mean, that was awesome. And I don't know what something like this would cost. But I can see in Keith's line of work where this thing would come in so handy. It'd be a great tool to have. And so anyways, that will be it with this video. We hope you enjoyed, and we'll see you next time. We just wanted to add this at the end of this video if other people are interested. This is a V-block that I've made years ago. It's my favorite V-block. This one is extremely accurate. But it has holes in the V area. It has for tap toes in here for strapping. You got a couple tap holes here for stops. You also got some 9/32 holes and some tap toes on the side over here so that you can even bolt things up to the side. And you have some 9/32 clearance hole for 1/4 20 with counterboards on that side, so you can bolt this to other objects, and then it's actually counterboard on this other side as well. This V-block is my favorite one. It comes in handy. I use it for a lot of stuff. But anyways, we had a viewer that he was interested in building one of these, and he asked if I could get him a drawing. So I got Fusion 360. I have this modeled up. If there's any other people that would be interested in this model and building a V-block like this, I'd be more than happy. If you shoot us an email, I'd be more than happy to send you the Fusion 360 file. We can send that to you, and then you have the model, and then you can tweak the model from there to whichever way you like. One of the nice features about this is because that V in here is extremely accurate. I use this a lot when I grind my smaller V-blocks. I'll set them in over like so, and then I can actually work with clamps and stuff in here, and I can get this part clamped down, and then I can grind the V, flip it over, grind the V, and what's nice about this, it makes grinding these other V-blocks a piece of cake, because everything, if the block is square, it's established, and grinding this V within this V, it's automatically central and everything, and it comes out good. But if I need something where I just need to stick in there, and let me grab another piece here. One of the videos I got a block like this. I need a nice 45 on there, so I could just set this down in here, finger clamp that, and now I got a nice 45. So it just comes in handy for so many things, and you will see it a lot in a lot of our previous videos. So if you are interested in that, we'll post our email address right after this. You shoot me an email and let me know that you'd like the Fusion 360 file on the V-block, and we'd be happy to send it to you. Another thing that we got going is you've seen our squareness checker. This one here is a non-adjustable one. You can check, as you've seen in the video, the squareness of objects. The Noga base has no adjusting on there. I like it stiff like this, so it does make it a little more difficult to get your needle. You got to fudge around a little bit to get it where it reads right. The adjustable ones are nice because you can just tweak them right down to less than a tenth. But this one has a smaller footprint. I don't know if you can see that. It's smaller, so it doesn't take as much metal. It doesn't need as much because you can see the footprint on there. And it doesn't have as many parts. We don't have the pivot. We don't have all the adjusting mechanism in there. And so we're going to offer this one for $550. If anybody's interested into a manual adjust one, it's going to be DC 53. The holder is A2, but the wear components will be DC 53. It does not come with the indicator or the holder, but you'll have this piece, and this piece. And so one thing that's nice about this squareness checker, we have a small footprint on this radius. So it makes it easy when I want to check the squareness of a V. I can get in there and I can pivot and I can check the squareness of the V. Really nice. A lot of times when you have the squareness checker and you got the great big footprint, you can't fit in these small places. With these, it works real nice. So anyways, if you're interested in the V-block, in having a model, I'll send it to you. And this is another item that we'll be adding, that we'll be selling. It will be cheaper because you don't have as many components. But again, unless you have some other fine adjust on there, it does make it a little bit more difficult to get that set just right. Thanks for watching.